Hello everyone, I'm back with a new video. As per the heading, we can know that what shall we learn today? Today we shall learn rational numbers part 2. That is, we shall learn something more about rational numbers. Till yesterday, what we have learned? We have learned what are rational numbers, and we have also learned to insert some rational numbers between two rational numbers. That is, we have learned to insert 2, 3, 4 or whatever may be some rational numbers between two rational numbers. So today we learn something more. See, this is the form of a rational number. We know p should also be an integer, q should also be an integer, and q should not be a 0. Now, what will happen if we divide this p with this q? What will happen? That is, if we divide this numerator with this denominator of a rational number, then what would happen? What will happen? Two possible cases may happen. Two possible cases may happen. What are the two possible cases? What are the two possible cases? Let us learn. If we divide p with q, the first case is that the remainder will be 0, and the division stops after a finite number of steps. Understand? What will happen? The first case is that if p is divided by q, the remainder will be 0. Means the division stops. And the division stops after a finite number of steps. After 1 step, 2 step, 5 step, 6 step, but a finite number of steps. That means the number of steps we can count, okay? It will stop after some finite number of steps. Then we will get some decimal expansion of this number. We will get something. A number will divide, we will get some decimal expansion or not. So what will be the kind of this decimal expansions? The decimal expansion thus obtained will also be terminating. Means the expansion which you have found will also be terminating. Like this case, suppose like this 0.34 or 0.963. See, terminating means it will stop. The decimal expansion will also stop after some finite number of steps. I hope you understand. This is the first case. What is the second case? I will repeat again, okay? What is the second case may arise? What is the second possibility may arise? In the second case, the remainder will never be 0. The remainder will never be 0, and the division will go on continuing. Understand the difference? You understand? Here the remainder will be 0 and the division will stop. And hence we'll get the answer. That is the expansion will get terminating. Okay? In the second case, the remainder will never be 0 and the division will go on continuing. And how will get the decimal expansion? How? Little different. How? Will the decimal expansion obtained in this case will contain, I'm giving arrow mark and writing here, okay? 1 digit, 2 digit, or a set of digits that will repeat themselves. Okay? See how different is that? In this case, the remainder will never be 0. The division will go on continuing, and what the expansion will get? In that expansion, there will be 1 digit or 2 digit or maybe a block of digits or a set of digits that will repeat. There is a surety, 100% surety that 1 digit will repeat or 2 digit will repeat or a set of digits will repeat, but they will go on repeating themselves. We'll get it more clear by some examples. First, let me clear once more. What will happen if you divide p with this q? two possibilities or two possible cases will arise. Not may, will arise. Obviously, two possible cases. Within these two, one may arise. Okay? One may arise. Not two together will not come to. In the first case, what can happen? What can happen? The remainder will be 0. The division will stop. And we will get some answer, that is some terminating decimal. Okay, the expansion thus obtained will be terminating. That means the expansion obtained will stop. Okay, will stop. In the second case, the condition is different. In the second case, the remainder will never be 0. That means remainder not 0 means what? It will go on. It will go on. In this case, it will go. The division will go on continuing. In this case also, we'll obtain some decimal expansion. What will be the expansion? The decimal expansion obtained in this case will contain how many digits? I don't know. Many digits, 1 digit, 2 digit, but the digits obtained in them, 1 digit, 2 digit, or a set of digits or a block of digits, that will go on repeating. That will go on repeating. Suppose like this. Suppose we have obtained like this 1.353. Then what? 3 digits like this. It can come. How many digits are repeating here? 3 digits. It can come like this also. 1.23, 23, 23, 23. Here how many digits are repeating? 2 digits. Here see 3 digits are repeating. And like this also can happen. 1.0.33333. Okay. Here how many digits are repeating? See, I said no. 1 digit or 2 digit or a number of digits, means a set of digits, 5 digits also, not 3 or 4, 5, 6, many digits that can repeat themselves. So this is the condition of that. This is the second case. Okay, sorry, not condition. Okay. Now will be more clear. After we will give much more examples. Okay. Now take us any rational number. Okay. What will take? 4/5. Now if we are say to find this, whether it will be a terminating or a non-terminating decimal, so we have to divide it first. What will put here? 0.5 is 40. This will be put into which case? First, which we have learned now. First case or second case? Which case? Obviously, this will be in the first case because we have got some decimal expansion, what? 0.8, and it has already what? Terminated. It is already terminated. Means the decimal expansion has stopped. Stop means रुक गया है और नहीं चल रहा है. ठीक है? The decimal expansion is already stopped. Okay. Now let us take other examples of rational number. 2/3. It is also a rational number. See, this is also a rational number. Here 4 and 5 are integers, and 5 is not equal to 0. Here also 2 and 3 both are integers, and 3 is not equal to 0. So let us divide again, and you can see what case it may come. It's first or second. Let us see. See, 2. It will not go 0. How much will come? 6, 18. Again it will come 2. You can understand something will happen. What will happen? 18. Again what? 2. You can understand what is happening? Dot. That means it will go on throughout our life if you do this one. Okay. It will take the whole class if you do. A whole period, whole life also. It will not going to finish. It is not going to finish. So it will obviously get chance to sit in the second possibility. Have what? 0.666. I said no. 1 digit, 2 digit, 3 digit, or a block of digits or a set of digits that will go on repeating. We'll get some decimal expansion. Obviously we'll get, but some digits will definitely repeat. See here, how many digits are repeating? 1 digit. It will go on repeating. It will go on repeating. It will go on repeating. So we have gone some of the examples also. Okay, gone through some examples and you can understand. See, so the second case. See how 0.6. So if you don't want to write like this, then you can write like this 0.6 bar, or you can write this 0.6 and put a dot on the above of 6. The number which is repeating, we can put above that number 1 bar, or we can give some dot. Okay. Now I will give you one chart. Make one chart and just make a summary of this what I taught today. Okay. So I'm rubbing. Okay, the topic I'm rubbing. Okay. So I'm writing a little bigger. Okay. The decimal expansion. What we have learned is the decimal expansion of a rational number. What will be the decimal expansion of number? Rational number will be either terminating. This I have already explained as well. I have given also example. Okay, will be either terminating, means the decimal expansion obtained will stop, or terminate will be either terminating or will be non-terminating repeating or recurring, or repeating is the same as recurring, so I will written this one in bracket. Okay, see this is summary what I have taught today. Again I am explaining, don't worry. The decimal expansion, that means we will divide the numerator of the rational number with the denominator. So some decimal expansion will obviously come. So what are the possibilities? What are the chances that decimal expansion of a rational number will be either terminating, means the decimal expansion will stop, or will be non-terminating, that means it is not going to stop. Like in the previous case, what you have done? See, 0.6666. Is it stopping? Boys and girls, it is stopping? No, it is not going to stop. See, will be non-terminating. Non-terminating means rukega nahi. Okay, you have heard this one. Will be non-terminating. It will never stop, but it will be repeating. Okay, this is the main thing. It will be repeating. रुकेगा नहीं, लेकिन रिपीट होना चाहिए. कुछ ना कुछ नंबर को रिपीट होना चाहिए. ओके, अगेन आई एम एक्सप्लेनिंग. विल बी आइदर टर्मिनेटिंग, या तो रुक जाएगा या तो नहीं रुकेगा लेकिन रिपीट होगा. ओके, will be non-terminating, that means it will not stop, but it will repeat some numbers, one number or two number or like this. It can also come like this: 2.2185, 2185, 2185. It doesn't mean only one number will repeat. 4 numbers, 5 numbers, 6 numbers, many numbers can repeat, but it will not stop, but it will repeat. Then it will be a rational number. Okay, so there are only two possible chances of a decimal expansion of a rational number. Okay, understand? Now one more thing we'll learn today. Okay, now see, one more note you can learn today. Maybe time is there. We'll finish that topic very soon. See, we have learned the decimal expansion of rational number. Now if I use these terms, decimal expansion, terminating, non-terminating, that you can understand, because I have explained in you little bit. I have used Hindi also. Okay, so you can understand. Obviously. See, the decimal expansion of a rational number. This is not to understand. You know what is decimal expansion, what is the rational, everything you know. The decimal expansion of a rational number can be expressed as a terminating decimal only when q, that means the denominator. Okay, I'm not writing, you understand, because I have said this repeatedly. Q, only when q will have prime factors of 2 or 5 or both. Okay, the decimal expansion of rational number, you know, we have learned that rational number can be expressed as a decimal also. Okay, can be expressed as a terminating decimal. I said rational number can be expressed as a terminating decimal also and as a non-terminating repeating decimal also. Only when q will have prime factors of 2 or 5 or both. Okay, 2 or 5. Okay, we can write here and also 2 and 5 or both. What is looking more better? 2 or 5 or both. Means it will have either prime factors of 2 or 5 or both. What is looking more better? Okay, it will have either prime factors of 2 or 5 or both. Let us take some example. See. Now suppose if you are said to find out, suppose any number like this 5 by 27. If you are said to find out whether this will be terminating or non-terminating, but you find out without division. See, if you divide, we can easily say. No? See, suppose you are dividing. See, easily you can say. Easily, if you can say this is terminating or not. If it stops, then it is terminating. If it not stops, then it will be non-terminating, repeating. Okay. But if the question comes like this, it is in your syllabus also. If the question without dividing, say whether it is a terminating decimal or whether the decimal expansion will be terminating or it will be non-terminating, repeating. So by looking, how can you say? But from this note, we can say how. See, suppose like this it is given. One example I am taking 1 by 25. Okay, simple example I have taken. 1 by 25. This number I have given. So if I divide, I can easily say whether it is terminating or non-terminating, repeating. But without division, if I said, then you can follow this procedure. What I said, the prime factors of q will have prime factors of 2 or 5 or both. So let us find out the prime factors of 25. That means q. This one is q, no? Let us take out the prime factors. 5. So what will become? 25 is equal to 5 into 5 into 1. So like this you can write 5 to the power 0 into 5 to the power 2 into 2 to the power 0. Like this you can write. Any problem? See, 5 is there, so power 2 I have put and 1 is there, so I have put 2 to the power 0. Anything to the power 0 is 1. Okay. So see, this has supported this statement, no? So what will be? It will be terminating or non-terminating, recurring? It will be terminating because the prime factors of q are factors of 2 or 5. Okay, understand? So it will be a terminating decimal. Okay, the decimal expansion will be terminating. Suppose you have taken another number, and suppose 2 also came, 5 also came, or some other number also came, 7, 3, any 11, any number came. Then what will decide? That is not a rational number. No, that will also be rational. That will also be a rational number. I said, but the decimal expansion will not be terminating. Why? Because we have to fulfill this case. If it needs to be terminating decimal, then we have to fulfill this case. What case? It has to be the q. The q means the denominator has to be the prime factors of q and or 5 or both. Okay. So we have finished this topic also. So I am stopping the class today here only. Next day we will begin a new topic. After full day's work, I am just managing some time for some online videos. I hope you like the videos and also subscribe the channel. Okay. And some of the class 10 boys are requesting to put some videos of their class also. So I hope very soon I can put their videos also. Okay. Till then, we'll meet in the next video. Thank you very much.